Hi everyone. In this video, we are going to discuss about how to find the equation of the tangent at a given point on a circle. Let's suppose we have a circle like this whose equation has been provided as x squared plus y squared plus 2gx plus 2fy plus c equals 0. That's the general form of the equation of a circle. And in that case, the center of the circle would be at negative g comma negative f. And let's suppose we have a point P on the circle whose coordinates are x sub 1 comma y sub 1, and we draw a tangent through that point, and we have to find out the equation of that tangent line, which is nothing but a straight line, right? So the task here is to find the equation of this tangent line. We have been given a point on this tangent line, which is the point P whose coordinates are x sub 1 comma y sub 1. So we know the point. Now somehow if we can calculate the slope of this line, then using the point slope form we should be able to determine the equation of the tangent line. So now let's try to see if there is a way we can calculate the slope of this tangent line. First, what I'm going to do is I'm going to connect C with P with a straight line, and this is nothing but the radius of the circle, and the radius has been drawn from the center onto the point. So this line segment, which is CP, it will be perpendicular to the tangent line. We have seen that in a previous theorem where we have proved that the radius drawn from the center to a point is always perpendicular to the tangent drawn at that point. So in this case, CP will be perpendicular to the tangent line, which is AB, let's say. Right? Now we have found a line segment which is CP that is perpendicular to the tangent line. So somehow if we can calculate the slope of the line segment CP, then we should be able to easily calculate the slope of tangent line. Now for CP, we know the coordinates of C and coordinates of P. So calculating the slope of CP is pretty easy. And what will be the value of the slope? Well, it will be something like this: y sub 1 minus negative f over x sub 1 minus negative g. And if we simplify this, it's going to look like y sub 1 plus f over x sub 1 plus g. So this is the slope of the line segment CP, and CP is perpendicular to AB. We know that the product of the slopes of two mutually perpendicular lines is equal to negative 1, and that's what I have noted here. The slope of CP times slope of AB will be equal to negative 1. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. And from here, what will be the slope of AB? Well, slope of AB can be written as negative 1 over slope of CP, and then let's plug in the value of slope of CP. So it's going to look like this: negative 1 over y sub 1 plus f over x sub 1 plus g. And if we simplify this, it's going to look like negative of x sub 1 plus g over y sub 1 plus f, and that is the slope of our tangent line. So in terms of x sub 1, y sub 1, g and f, which are all known quantities because we have been provided with the equation of the circle, that means g and f are known quantities, and similarly we have been provided with the coordinates of the point P, which are x sub 1 and y sub 1. They are also known quantity. So now we have been able to determine the slope of the tangent line. And now that we know the slope of the tangent line and also we know a point on the tangent line, we can use the point slope form of the equation of straight line. Now using the point slope form of equation of straight line, how is the equation of this straight line going to look like? Well, it will be like y minus y sub 1 is equal to slope of this straight line times x minus x sub 1. And if we plug in the value of the slope, it's going to look like negative x sub 1 plus g over y sub 1 plus f times x minus x sub 1. And if we simplify this little bit, the equation is going to look like this: y minus y sub 1 times y sub 1 plus f is equal to negative x sub 1 plus g times x minus x sub 1. And if we bring the x terms to the left hand side, then the equation is going to look like this: x sub 1 plus g times x minus x sub 1 plus y sub 1 plus f times y minus y sub 1 is equal to 0. This is one of the forms, and we are going to see another form. Let's get rid of the parenthesis. The equation going to look like this, and in the next step we are going to get rid of the other parenthesis. Then finally the equation is going to look like this, and then I am going to reorganize the terms a little bit. The equation can be written like this: x sub 1 times x plus y sub 1 times y plus g times x plus f times y minus x sub 1 squared plus y sub 1 squared plus g times x sub 1 plus f times y sub 1 is equal to 0. Next, I am going to make a couple of notes on the left hand side here. We have been provided with the equation of the circle, and we have been provided with the coordinates of the point P, and because point P is on the circle, its coordinates must satisfy the equation. So from that aspect, let's see what we can figure out. The equation of the circle has been provided as x squared plus y squared plus 2gx plus 2fy plus c equals 0. And if we substitute x sub 1 and y sub 1 in place of x and y, then the equation is going to look like this: x sub 1 squared plus y sub 1 squared plus 2gx sub 1 plus 2fy sub 1 plus c equals 0. And from here, I am trying to find out what is the value of this little quantity that is inside the parenthesis, which is x sub 1 squared plus y sub 1 squared plus g times x sub 1 plus f times y sub 1. Now on the left hand side, this equation can also be written like x sub 1 squared plus y sub 1 squared plus g times x sub 1 plus g times x sub 1 plus f times y sub 1 plus f times y sub 1 plus c equals 0. And in the next step, you see what I did? I now kept x sub 1 squared plus y sub 1 squared plus g times x sub 1 plus f times y sub 1 on the left hand side, and then I brought all other terms onto the right hand side. So on the right hand side we have negative of g times x sub 1 plus f times y sub 1 plus c, and that is the value I am going to substitute within the parenthesis there in the yellow color. So now let's get back to our original equation here. Our equation can be written like this then: x sub 1 times x plus y sub 1 times y plus g times x plus f times y minus, within the yellow parenthesis, what I have substituted, I have put negative of g times x sub 1 plus f times y sub 1 plus c, and all of this is equal to 0. That's our original equation. I have simply used the value of x sub 1 squared plus y sub 1 squared plus g times x sub 1 plus f times y sub 1. I have simply plugged in the value that we derived on the left hand side. Now let's get rid of the parenthesis. It will be x sub 1 times x plus y sub 1 times y plus g times x plus f times y plus g times x sub 1 plus f times y sub 1 plus c equals 0. And from here, if we reorganize little bit, we can write it as x sub 1 times x plus y sub 1 times y plus g times x plus x sub 1 plus f times y plus y sub 1 plus c equals 0. And that is the other form of the equation of the tangent line. We could also write it like this. We can say x times x sub 1 plus y times y sub 1 plus g times x plus x sub 1 plus f times y plus y sub 1 plus c equals 0. So whichever is easier for you to remember, you can go with that. Next, I am going to take a situation when the center of the circle is located at the origin. When the center is located at the origin, obviously the coordinates of the center would be 0, 0. That means g will be equal to 0 and f will be equal to 0, and r will be equal to square root of g squared plus f squared minus c, and that will be equal to square root of negative c. And if we take a square on both sides, we can say r squared will be equal to negative c. And now if we think about the equation of the tangent line at point P, whose coordinates are x sub 1, y sub 1, then we can simply plug in the values of g, f, and c. In the first round, I have plugged in the value of g and f, so I have written the equation like this: x times x sub 1 plus y times y sub 1 plus 0 times, in place of g I am writing 0. So 0 times x plus x sub 1 plus 0 times y plus y sub 1. Here in place of f I have used 0 plus c equals 0. And if we simplify this, the equation is going to look like this. And if we bring c to the right hand side, our equation will look like this. And finally, let's replace the value of negative c with r squared. So our equation will look like x times x sub 1 plus y times y sub 1 is equal to r squared. And that is the equation of the tangent line at the point P, whose coordinates are x sub 1, y sub 1, for the circle whose center is located at the origin. I hope things are clear up to this point. Next, we are going to take an example. Let's suppose we have an example like this that says find the equation of the tangent at point P, coordinates 3, negative 2, on the circle x squared plus y squared minus 13x minus 5y plus 16 equals 0. Now let's get started with the solution. We have been provided with the values of x sub 1 and y sub 1. X sub 1 is actually the x coordinate of point P, which is equal to 3, and y sub 1 is the y coordinate of point P, and that has been provided as negative 2. And also from the equation of the circle, we can clearly see that 2gx is equal to negative 13x, and from here we can say g will be equal to negative 13 over 2. Similarly, 2fy is equal to negative 5y, and from here f will be equal to negative 5 over 2. And also the constant term is positive 16, that is the value of c. Now let's try to derive the equation of the tangent line. The general equation of the tangent line is like this: x sub 1 times x plus y sub 1 times y plus g times x plus x sub 1 plus f times y plus y sub 1 plus c equals 0. And here all we need to do is we need to plug in the values of x sub 1, y sub 1, g, f and c, and then simplify it. So after plugging in the values, the equation going to look like this. All I have done is I have used 3 for x sub 1, negative 2 for y sub 1, negative 13 over 2 for g, negative 5 over 2 for f, and positive 16 for c. If we simplify this a little bit, it's going to look like this. And in the next step, I'm going to multiply this by 2 on both sides of the equation. Then the equation will look like this. 6x minus 4y minus 13 times x plus 3. So I have written that as minus 13x minus 39, and then minus 5 times y minus 2, that will become minus 5y plus 10, and then 16 will become 32 because we are multiplying each term by a 2 on both sides of the equation, and that will be equal to 0 times 2, which is 0. On the right hand side it will be 0 times 2, which is nothing but 0. And now if we reorganize the terms a little bit, the equation is going to look like this. Negative 7x minus 9y plus 3 is equal to 0. And then we can write it as 7x plus 9y is equal to 3. And that is the equation of the tangent line at point P on this circle. And that is our answer. I hope everything made sense. Thank you for watching. See you in the next video.